Okay, hi, I am recording this video as part of the extra credit assignment for Mr. Wellman's physics class. The original assignment had 3 problems. I just completed the first 2, and I'm going to talk about them now. First problem here um, has a scenario where you have a beam leaning off of an edge, and we're asked to find how far out a person of mass 75 kilograms can walk out towards the right before tipping the 100-kilogram beam over. So essentially, this is a center of mass problem, and how I set up my equations, as you can see, is with my cursor here, I have the center of mass for the right side of the beam, like past the fulcrum. I'm making the fulcrum the edge of the table that the beam's sitting on. And so on the left-hand side here, I have the center of mass of the left part of the beam. That's going to be in meters. Then I have the mass of the beam to the left, and then times the unit of gravity. Then on the right side of the equation, I have the center of mass of the right-hand beam, the mass of the beam, and the acceleration due to gravity. And then in addition, we have the mass of the person times gravity, and then their position, which we're going to solve for. So you see, I've arranged this equation into that. So solving for the position of the person. So we have the mass of the left-hand beam times the center of mass minus the mass of the right-hand beam times the center of mass of the right-hand beam, all divided by the mass of the person. You see that the units of grams cancel, and also we have kilograms in the numerator and the denominator, so those cancel too. So our final units are going to be meters, which is good because that's what we wanted. So you see here, when I've plugged in my values, the answer to the problem is that the individual can walk towards the right-hand side 1.3 meters before the beam tips. Okay, so moving on now to the second problem. If this comes up, yes. In this problem, we're asked, we have a scenario where we have a beam balancing on a fulcrum, and at the edges of the beam there are masses. And so we're trying to figure out what is the mass of the weight on the leftmost portion of the beam. What mass does that have to be in order for the beam to cancel? So intuitively, when I think about this problem, it's that we have such a greater distance on the right-hand beam that the mass on the left-hand beam is going to be large. It's going to be larger than the mass on the right-hand beam. And so I've set up my equation here where we have the mass of the left-hand beam times the center mass of the left-hand beam times the unit of gravity plus the mass of the left-hand the left-hand mass times the distance of the left-hand mass times gravity again equals the mass of the right-hand beam times the center mass of the right-hand beam times gravity plus the mass of the right-hand beam times the mass of the weight on the right hand times its position. So I've rearranged that there. As you can see in the next step of the problem, solving for the mass of the weight on the left-hand beam. And so you see, once again, our units of gravity cancel. We have meters in our numerator and denominator of my equation, so our units are going to cancel to kilograms, which is good because that's what we want. So you see here, once I've plugged in all the values and solved, the mass of the left-hand weight must be 135 kilograms in order for the beam to balance along the fulcrum. That's all I have. Once again, I do not have the third problem, so this is it. Thank you.